Alright. So guys, for you that don't know me, my name is Mark Schrader. I work for Droid. I'm a project and support engineer over here. So whenever it comes to projects and support, you can always talk to me. Always here to help, always enjoy helping people. That's one of my things that I like to do, is I like to help people. That's one of the reasons why I'm doing this webinar, is I want to help people understand how the comms work on these iQF-PLCs. And if you don't know what the iQF-PLC is, it is our Mitsubishi FX5U PLC. Okay. So let me get going here again. Alright, so introduction. This agenda is, I'm going to talk quickly about introduction, quickly about what Modbus is. I'm going to run you through a scenario, then I'm going to show you the actual setup. Okay, and then I will show you how to do it in a video, how we practically actually did it for you guys. Okay, and as you can see at the bottom of the screen, there's my email address, marks@adroid.co.za. If you have any questions at all that we don't cover in this webinar, or I don't cover at the end when we do our chat, then I will gladly be able to assist you through there. Okay, so let's talk about this webinar. Why are we doing this webinar? The PLC contains the ability to communicate on Modbus as a slave and a master. Now in this webinar, I will show you how to set up the iQF-PLC as a master, which will communicate and control the Mitsubishi E700 VSD. So as always, we're going to use GXWorks 3 to set up the Modbus communication. So in other words, no third-party application at all. This is all done through GXWorks 3. And yeah, it is relatively quick and easy. For me, of course, for you might not be that easy when you first do it, but when you do it the second, third time, it's a lot easier. Okay, let's talk about Modbus. So Modbus is an application layer messaging protocol positioned at level 7 of the OSI model. This provides a client-server or master-slave communication between devices connected on different types of buses or networks. Okay. So the industry's serial de facto standard since 1979. It was developed by Schneider, by the way. So it's not an Android protocol, it is a Schneider protocol. So Modbus continues to enable millions of automation devices to communicate. Today, support for the simple and elegant structure of Modbus continues to grow. Okay, so Modbus is a request-reply protocol and offers services specified by function codes. Okay. When we speak about function codes, these are the function codes that we talk about. Okay, so this is not a complete list. There are a lot of other function codes. Now, when they talk about the function codes, these are the subcode is the type of address that you can speak to on any device, any Modbus device. So if you see a subcode of 01, you know that you're reading a coil. Okay, and a coil is obviously an on-off statement. And you can obviously turn a coil on or off from your own side. Okay, these coil addresses are normally start with 5 zeros and a 1, or 5 zeros and a 2, and so forth. And yeah, you can read and write these coils. Okay. Subcode 2, we look at you read discrete inputs. Discrete inputs are inputs that come from the field. So in other words, any switch, for example, any button, anything, proxy, for example, that will come through as a discrete input. Okay. Also, it's only a read status. Okay. So it will, these addresses start with a 1, and they're 1001, 1002, and so forth. Okay. Then function code 3. This is the better known type addresses with Modbus. It's where you read your holding registers. Now, your holding registers always start with a 4. Okay, so you'll be 40,001, 40,002, and so forth. Function code, function code 404 is read input registers. Okay, so your input registers are normally start with 3. So you'll be 3001, 3002, and so forth. Okay. Oh, by the way, subcode 01 for read coils, that's only read coils, that's not write coils. Subcode 05, that is where you write to a single coil. So that will be 00, 5 zeros and a 1, and so forth. Okay. And then you write your single register, which is subcode 06. Those are also your 40,000 and whatever registers. Okay. These are important. I'll especially show you guys later on your read input registers. So subcode 03, which is read your holding registers, and write your single registers sub 006. Keep that in mind because I will be showing this to you as part of the video. Okay. Alright, so the scenario is we wanted to create a connection from one of our iQF-PLCs to an it's a F700, not F800 VSD using Modbus. You can do this with a F800 VSD as well. Okay. So what will we need for this exercise? Mitsubishi iQF-PLC, also known as the FX5U PLC. Mitsubishi E700 VSD, RS485, that will be your actual wiring, and GXWorks 3 engineering software. Okay. So what is the solution? These are 5 steps that you need to basically take when doing this whole program. You can download a sample program from the My Mitsubishi website. Okay, so step 1 would be wiring and configuration between the VSD and PLC. Step 2, set up the parameters on the VSD. Step 3, set up the PLC program. Step 4, convert/download program to the PLC. So that's when you actually check the PLC program is okay, and you actually write the code to the PLC. Okay, and then of course you test your connection and you do your control between your specific 2 devices. Okay. So wiring and configuration. Okay, so using the PU connection, that's the PU connection on the Modbus, on the VSD itself. You set it up as a Modbus network port, and it enables communication operations from a Modbus master. Okay, when the PU connector is connected with the Modbus master by using a communication cable, a user program can run and monitor the inverter or read and write the parameters. Okay. So wiring, if you look at the wiring over there, if you look at your pin numbers, it is an RJ45 type connector, your PU connector. If you look at your pinouts, those are your pinouts. I'm not going to go through every single one of them. Okay, so you need to make sure that your RDA goes to SDA on the other side, SDB on this side goes to RDB on the other side, and so forth and so forth. Okay. Very important, if you don't do this wiring convention correctly, you will not get communications between them at all. Okay. Yeah, it's the typical wiring setup anyway. So we go from this page, I'll show you the wiring setup anyway. So this is how you will set up your connection. So for the computer side terminals, it doesn't need to be a computer. That in this example, it is the PLC. Okay. So now we look at the VSD setup. Very important. These are the typical parameters that I would set up to get the PU port ready for Modbus communication. Okay. I'm not going to go through all of them with you. The ones that are very important is parameter 79. Okay. Parameter 117, that's the actual station number that you're communicating with. With Modbus, that's extremely important. Okay, if you don't know which station you're talking to, you're not going to be able to communicate with that station at the end of the day. One of the reasons why they give station numbers is because we are communicating on RS485. It is oftentimes a multi-drop type system. So you will, or daisy chain, as some people like to call it, you can have, I think it's up to 255 stations, if I'm not mistaken, and 254. I'm not exactly sure. So you can have up to 255 stations, I think. Don't quote me on that. And each station needs a number. So you need to tell the PLC which station you're talking to. So if you have 3 VSDs in the field, for example, you need to give each VSD its own station number, or else the PLC will not know what it's talking to. Okay. And of course, let's go through these important parameter 549 protocol selection equals 1. That means that you are using the Modbus protocol. Okay. And 551, your operation command source selection is 4. In other words, you're telling it it's receiving its commands via the RS485 port or the PU port. Okay. So let's look at the iQF-PLC solution. So what we're going to do, step one is obviously set up the parameters of the PLC. This is always the first thing that you do. Okay, so we're going to open a new project in GXWorks 3. We're going to tell it that it's a FX CPU, FX5 CPU, and the programming language ideally would be FDB/LD, which is function block slash ladder. Okay. So first thing, like I said, we set up the parameters. So we're going to go and set up the RS485 serial port parameters. So you go navigation window, parameters, 5U, FX5U CPU, module parameter, and then you go to 485 serial port. Okay. Once you've done this, you're going to use your mouse like I show over there, and you're going to click on the communication protocol type, and you're going to select Modbus RTU communication. Once you've done that, once you've selected Modbus RTU communication, for this example, the parity bit is even, okay, because that's what we set it up as inside of the VSD, and the baud rate is 192000. These need to be exactly the same as you set it up in the VSD, or else your communications just will not work. Okay, this is extremely important when it comes to serial type communications. Okay, so what you do is you click on check, and then if it says no error found, then you click OK on that, and you're basically done with setting up the parameters for the RS485. Okay, and then apply. All right. So once you've set that up, we actually need to have a look at the Modbus registers inside of the VSD that we need to communicate with. Okay. Apologies, it's not the CS80 VSD. It is the F700 VSD. Okay. So you, inside of your VSD, if you look at 40002, that is your inverter reset. 40003, you put that on, you clear the parameters, which ideally you don't want to do. 40004, you also clear parameters. Important one you want to have a look at here is 40009. Now 40009, those, if you look at the right hand side over here, those are your bits, the command bits that you write to that word. So in other words, bit 1 will be stop command, bit 0 is stop command, sorry. Bit 1 is your forward rotation command. And then of course, if you've set these parameters over here, once you've turned on bit 3, it will go to the high speed, middle speed, low speed. But ideally, I don't really like using them. I like to set the speeds straight from the PLC using word. It's this word over here, 40013. Okay. And of course, if you have a look down here, the parameters, you can actually read the parameters. Okay, so if you look at those addresses over there, you'll be able to actually read the parameters through to your PLC. All right. Now you need to use a function block in order to communicate with this F700. Now that will be in your FDB ladder side of the program, or any other Modbus device. In the FXU5 master function, communication is executed with the slave station using the ADPRW instruction. Okay. The nice thing about this instruction is it's a read-write instruction. Okay, so you can read and write to the slave station using the function code which is supported by the master. Remember, we spoke about the function codes earlier, 01, 02, 03. These are the function codes which they are speaking about over there. Okay. So setting up that port, if you have a look at that function block diagram, if you can see on the left there, that's enabled S1, S2, S3, S4, S5, D1, enable on the outside, enable out on the right hand side, and D2. Okay, and this is basically what they stand for. So S1 stands for your slave station. If we go back, S1, that's where you will set your slave station number. So that will be that one address that we set up in the VSD. S2, that will be your function code. If you remember, this is our function code that we set up, that we pick up earlier. So if you have a look at this function code, that's the function code, that's 01, 02, 03. So that's what you would be set up setting up over there on S2. Okay. S3, that's a function parameter depending on the function code. Okay, so that's read or write. Function parameter depending on the function code, that's also another one. Okay. And then, yes, depending on what you're reading or writing, as you go down with the list. I will show this to you guys a little bit later. Okay. So the first thing you always do, or the second thing you always do, the first thing you always set your parameters. This is how I program, by the way. I normally set my parameters first, and then I will go and set my labels or variables in the program. Okay. So as you can see on the right hand side there, these are the addresses that are set up. So in other words, I will basically switch on bit M11 to start the PLC, for the PLC to start the VSD going forward. Okay, and I will write to D112 in order to change its speed. Okay, and then you can monitor your parameters all the way from your torque down to your overload relay. This is just as this example. Okay, you can monitor all the parameters if you want, depending on how you actually set up this program. Okay. Then your output frequency, these are ones that we going to read. Output voltage and output current. Okay. So once you've done that, now you're going to add new data. You're going to add a new program block, and that's what it's going to look like, the program block. And you are going to drag and drop your ADR PRW block into the programming area. Okay. But first you need to click on where I've put number 1. You're going to click on the element selection screen, and then it's going to open up your element selection. Normally it's on the right, and you're going to drag and drop the box into there. Okay. So the next thing you're going to do is you're going to add the parameters. Okay, so remember I said earlier H1, that it's always in hex, by the way. Well, not always. PLC likes it to be in hex. So hex 1, that is the address that you're talking to, the PLC address. So you want to talk to H1, which is VSD address number 1, Modbus VSD address number 1. H3, that's the parameter that we want to use, that we spoke about, the function code. It's going to be H3. In other words, we want to read from this device. Okay. And H3E7 basically means we are reading from address 41,000, sorry, at the end of the day. So this is, we are reading the parameters, and we're going to read the next 10 addresses from that. So in other words, we're going to read from 41,000 up until 41,009. And then this is where we're going to read it to. This is where the address is going to be at the end of the day. Okay. And then we're going to do the same when we read the values. Okay, so I'm not going to go through this again. H3, which is function code 3. C8, that is address in hex, that is address 200. Remember, there's always an offset of 1. So we want to read from 40,201, and we are going to read the next 3 addresses, which is your output frequency. It's going to be your output amps, and it's going to be your output voltage. Okay. In the next page, this is the write commands that we're going to use to write to the PLC. Okay, so remember earlier I said 40,009. We're going to write basically from bit M10 to that register, and that is going to write the stop-start commands to the PLC, the bits. Okay, so as you can see there is H6. This is telling us that we want to write to the PLC, from the PLC to the VSD. Okay, and H9, because it's got a 1 offset, it's going to be address 8 plus 1, and in other words, we are going to read from address 40,009. Okay. So these are the write commands. These write commands we're going to use to set the speed of the PLC, of the VSD. So we're going to write again. We're going to look at address D, hex D, and the next two addresses after that. So we're going to look at 40,015 and 40,014. Okay. Guys, if you have questions, please wait until after the presentation, and I will gladly answer any questions that you have. Okay. So you rebuild your program. Once you've rebuilt the program, it basically checks for any issues, programming issues, syntax faults, and if everything's okay, you can then download your program to the PLC. Okay. So you say write to PLC, program parameters, and you say yes to all as you write it. Okay. Thank you for that, guys. Quickly going to show you the video. I'll talk you guys through the video. And if you have questions after that, I will gladly help you guys. Okay. Alright, so we start the video. I'm going to start a new program. We started the new program. The next thing we're going to do is we're going to change the parameters. Parameters is the first thing that we want to change, like I said before. So RS485 serial ports. I'm going to select the communication that you want to use. So we're going to use Modbus RTU communication. And then we're going to change the parity and the baud rate. So it needs to be even and 19200. And then we're going to say check, and if everything's fine, we say okay. And quick thing that we didn't show you in the slides is you need to set up your slave response timeout. I normally make it 1000, which is 1 second, just to get a quick response back from the VSD. Okay. So once that's done, we are going to change we're going to go to labels, and we are going to change the global variables. I'm going to quickly type all of these variables in for you. Very, very quickly. And there you go, they're all typed in over there. Check. If everything's okay, then as I show over there, those are the variables that I created. I showed that to you guys a little bit earlier. Okay. And change the local labels, which is something I didn't show you guys earlier. You're just local variables to the program block. Okay. So once that's done, now we want to add the program, the actual program. Quickly type that in for you. And there it is. As I said earlier, we're looking at address 1. Reading, so we're using function code 3, and we are reading the parameters at the end of the day from address 41,000. Okay. Next thing we're going to do is we're going to add more reads. So now we're going to read the values from the drive. These values are the frequency and the current and the voltage. Also we're reading, I showed you guys this a little bit earlier as well. And now we look at adding the write commands. We're going to write to address 40,014. So H6 means we are writing, that's the function code. And we're writing from K4M10, which basically means that you're writing the next 16 bits to the word. Of course, a word makes up 16 bits. So each bit from M10 up to M25, we're going to be writing into that word over there. Okay. And then the next thing we're going to do is we are going to write to the speed, to control the speed. So H6 again, we're writing to that address. the next two addresses, and we are writing to that register in the PLC. So D112, as I spoke. So you'll use D112 to set the speed. Okay. Rebuild, everything is fine, hopefully. Does a quick check. It's done the check, it's happy. And then we're going to write to the PLC. Set up our connection quickly. Make sure we got a connection. And then the next thing we do is we write the program to the PLC. Select all. Execute. Takes a few seconds to write the program. And there it's just telling us we need to reset the PLC, which is something that I'll do now. And there I go, reset the PLC. You'll see the red light flashing, and then you turn it on. And as you can see, there are two lights, SD and RD. That's basically telling us the communications between the PLC and the VSD drive. That's always a good indication to show you that there actually are comms happening. Okay. So now that we know there's communication happening, now we want to actually start the drive using the PLC. So I'm going to quickly do that for you. We're going to go to M10, sorry, D150. D1150 is where we read the parameters. As you can see, those are the parameters. I don't know them by heart, but parameter 1 is the torque. Parameter 2 there is the maximum speed, and I think parameter 3 is the minimum speed that you can set it at. Okay, so whenever you start up the drive, it will never run slower than 20 Hertz. Okay, so let's go to M10. Now M10, we're going to switch on M11, and as you can see, I've turned on M11, and that will start up the drive, as you can see in the bottom right corner. As you can remember, I said that the minimum speed will be 20 Hertz, so it will never run lower than 20 Hertz once you started it. Okay, so I want to change the speed, but before we change the speed, I want you to have a look at D120. It shows you 2000, which basically means it's running at 20 Hertz, and the voltage there under D122 is the voltage that the drive is running at. Okay, so I'm going to set this to 45 Hertz, so 4500. And you'll see it will start ramping up to 45,000 or 45 Hertz at the end of the day, because that's what we wanted it to do. Okay, and you can see there under D120 that it's running at 45 Hertz, and the voltage is also up on D122. So switch off the drive. Once we switched off the drive, you'll see it will run down on the right hand side, and it has stopped. Okay. Let me see, is that all? That looks like all. Let me quickly go back to this page. Let me see. Okay guys, thank you for having joined me. If you guys have any questions, please ask me now quickly. If you don't have a question for me now, but there's something that you think about later, please email me or even give me a call. My contact details are there. You can speak to me any time of the day. I'm not scared to help people out, like I said earlier. So if you guys have any questions, please let me know. If you don't have questions right now, it's okay. Alright, I don't see any questions over there. So nothing there. Cool guys, then I will thank you for listening. Thank you for tuning in. I hope you guys have a good rest of your week. But before you do anything, I want you guys to subscribe to our channel. Okay, and there's a little bell icon which basically tells you that every time we upload something that you'll be told about it. And yeah, tell your friends about us. Come and join us for the next webinar. The next webinar I'm doing is next Thursday at 11. I'm going to be talking about CC-Link, serial CC-Link that is. The week after that, I'm going to be talking about CC-Link IE, which is the Ethernet version of CC-Link. If you're interested in that, come and listen to us. And yeah, have a good one. I'll speak to you guys next time. Cheers.